the first question I want to go, and this is going to be on the test tomorrow. This is asking you to find the midpoint of a segment with these endpoints. Okay. Remember, all you have to do, however you want to write the formula, if you want to call that point A and that point B, your formula for finding the midpoint is A plus B over 2. It's the average. Okay. If you want to call it X1 and X2, it's X1 plus X2 over 2. Okay. So all I've got to do is -4 plus 9, divide that by 2. I get 5 over 2. Okay. Now, you're going to, some of you are going to go on to take other classes. You're going to go on and take stats. You go on and take college algebra. You go on and take algebra 2, that kind of stuff. So I teach all of those classes. And so far this year, in each one of those classes, we have had multiple times to find the midpoint of something. And we don't go back and say, remember what we did in geometry, and reteach how to do that. The question is, how do I find a midpoint? Somebody throws hands up. It's the average of the endpoints, and we go on. Okay. So what I'm trying to kind of get us to visualize, especially in this class, because there are so many things in this class that carry over into other courses, is the importance of one concept, because it's going to play over into other courses. If things were not important like that, I probably wouldn't talk about them. Does that make sense? If I wasn't going to ask you about something, or potentially ask you something on a test or a quiz about a concept, I wouldn't teach the concept. I wouldn't waste your time or my time. Does that make sense to everybody? So that's just something to keep in mind as we progress through the year. I want to make sure that we remind ourselves and remember that math is something that is, you build upon it over and over and over again. If you forget one of those underlying principles, the things that you're building are going to be hard to do. Okay. This question here, the coordinates of a point T are 0, T, and it tells you the midpoint, okay, or 0, 2. It tells you the midpoint is at 7, -8. Now, I'm just going to draw like a rough sketch here. I'm not going to really make my my intervals consistent, or I'm probably going to number things, but I'll make sure these points are in the right coordinates or quadrants. So 0, 2, X being 0, Y being 2, so maybe that's where T is 0, 2. S is at 7, -8. So that's going to be in the fourth quadrant. We see what the question is. It says that's the midpoint. So this is an endpoint. I want to find out what is the other endpoint down here. If I can spell it right. Endpoint, okay. And it's going to be my x2, y2. Does that make sense? Or depending on how I decide to do it, my formula might be x1, y1. But it's one of those two sets of coordinates. This is the x sub m, y sub m. Does that make sense to everybody from our formula? So this question got flagged for me because a lot of people missed it. Okay, so we'll go through it. So the midpoint, they're calling it S. In previous questions, I've called it capital M. But it's going to be an x comma y. And remember, to find the midpoint, all you do is you take the average of your x's for your endpoints, divide by 2, averages of your y coordinates. Now I'm going to fill in the things I know. So this was x1, y1. This is xm, ym, x2, y2 are my unknowns. So as I plug things through, this information is going to go right there. This information, x1, y1, is going to go there and there. And that's going to leave me with this information being x2 and y2 that are unknown that I'll be able to solve for. So plugging that information in, so we'll have point S of 7 comma negative 8 is equal to, now x1 is my 0, so I'll say 0. x2, I don't know that, so it's just x2 all over 2. y1 is this 2. y2 is unknown. We'll divide by 2. So it's the exact same. If you can do one of these like this, finding this endpoint, then they're all exactly the same. It's just the different numbers that you substitute. Now, we talked that that number right there equals that expression right there. That expression is how we generate that x value of our midpoint. So I'm going to relate those. I'll say that 7 is equal to 0 plus x sub 2 over 2. And then that y value correlates to that. So we'll write our second equation as negative 8 is equal to 2 plus y sub 2 over 2. So now you've got these two equations that you can go through and solve. What would you do first here to get rid of the fraction? Multiply both sides by 2. So I'm going to get 14 is equal to 0 plus x sub 2. That's already solved for x sub 2, so that's the coordinate. And you would do the same algebra here. First, you'd multiply both sides by 2, so it gives you negative 16 is equal to 2 plus y sub 2. Subtract 2, you get negative 18 is equal to y sub 2. So my ordered pair is going to be 14 comma negative 18. And what I always do is I'm going to come back over to the quick sketch that I drew and just guarantee myself that is that yellow coordinate down there, or yellow point down there, x2, y2, does it satisfy its position? Meaning, this 14, negative 8, is that a fourth quadrant point? That makes sense? If I got back like positive 14, positive 18, that would be first quadrant, and that would not be then collinear with T and S, and I would know I've done something wrong. Okay, and I would go back through my work. If you are using Desmos, okay, you can tell Desmos to plot points by just typing in like 0, 2. We had 7, negative 8. And then what was it, 14, negative 18. And it'll plot those points, and you can kind of zoom out and look at those 3 points, and does that look like it puts that point there in the middle? Does that make sense to everybody? Okay. Guys, so here's the thing right now. I'm speaking. So we're taking graph, it says graph these points, and then draw rectangle ABCD. Okay, so when we plot these points, and I'm just going to do this quickly, it allows me to do it a lot quicker and cleaner if I do this stuff in GeoGebra or Desmos. So A is negative 6, negative 5, B, negative 3, negative 8, C is located at 1, negative 4, and D at negative 2, negative 1. All right, so there's my rectangle. They asked me to draw it. So in Math Excel, there's like a picture that you got to click on. What is the correct picture? So it's just seeing if you can plot those things correctly. It then talks about creating, it says find the midpoints of AC and BD. So AC is that segment right there, right? Okay, so I'm going to construct AC and BD, and let's color those real quick. All right, so talking about those red segments, it wants to figure out what are the coordinates of the midpoints of those red segments. So let's just look at working with A to C. If I'm doing A to C, we want to find the midpoint. Midpoint formula says add your x's, divide by 2. Okay, so if I want to find midpoint of AC, let's just say midpoint segment AC, add your x's together. So you're going to take that x and that x. So that gives you what? Negative 6 plus 1. You're going to divide by 2, right? You're going to take that y plus that y. So negative 5 minus 4, divide by 2. That's going to give you, I'm going to leave them as fractions, negative 5 halves, and it's going to give me negative 9 halves. Everybody okay with that? Okay. Now, I'm going to do the midpoint of BD. So now you're going to take that x value and that x value, add them together. So negative 2 plus a negative 3 just turns into minus 3 all over 2. And then do the same thing with the y. So negative 1 plus negative 8. So it turns into negative 1 minus 8. And I get, again, negative 2 minus 3 is negative 5 over 2. Negative 9 over 2. What do you recognize about the midpoint for both of those segments? The midpoint of that segment there and the midpoint of that segment there. They're the same, okay? So what that tells me is that when I have two segments who share the same midpoint in the coordinate plane, it tells me that those two segments actually bisect each other, okay? So if I kind of prove that to you real quick with actually locating the midpoint, okay? Now I'm going to ask this thing to find distance. We could do this distance, be a little bit more difficult because of the fraction, but we could use the distance using the distance formula, and that's when I ask GeoGebra to show that distance, it's using the distance formula, okay? That's what it's coded with in the background. Let's round this to 3 decimal places. So A to E is 3.536. E to C is 3.536. So that guarantees that E was the same, or was the midpoint for that segment there, A to C. If I go D to E, you get the same number. If you go E to B, you get the same number, okay? And that's what they're asking about in this question. When we have two, and this is in a rectangle, when we have two diagonals bisect each, or share the same midpoint, then that tells us that the diagonals bisect each other, okay? Now, because all 4 of these are the same, what's it tell you about the diagonals of a rectangle? What's it tell you about the lengths of the diagonals of a rectangle? They're the same, okay? So if you guys ever, in construction, people say, are things square? Do things have right angles, okay? One way of measuring that and determining that quickly without a protractor is to go from opposite corners and measure to make sure that that distance there is the exact same as that distance there, and that will guarantee me that I'm at least dealing with a rectangle, and rectangles have right angles, right? 4 right angles. So those are kind of little things that we talk about in this class that you can then use in real life. When we deal with segments that are bisecting each other, let's say, let's see here, let me create just a generic segment and then find its midpoint. Well, I can't. Where did it go? Let's do this. well, I've messed up my, I'll show you, it'll come up in chapter 6. I've messed up my tab up top, and I've deleted some of the functions that it does. I was looking for a segment bisector that actually creates another segment. So I'll mess around with that and get that back and show you later on. But does that question make sense on how we address that? If you get two segments that have the same exact midpoint, the two segments then are bisecting each other. It doesn't necessarily mean that the overall segments are identical. That just happens specifically in a square. Okay, so this, if we didn't have the rectangle or square, this segment could be longer and this segment could be longer. If they share the same midpoint, so we'll get them on the same midpoint, that would be the same as that, that would be the same as that. Does that kind of make sense, everybody? Okay, so all four parts don't have to be the same if they share a midpoint. This is a parallelogram. Is that okay? You guys have any specific questions or anything? All right.